TW Philadelphia Resins is a major manufacturer of epoxy grouts and epoxy chocks used for the critical alignment of industrial machinery throughout the world. Examples of this machinery are reciprocating compressors, turbines, generators, motors, pumps, and other critical path equipment. ITW Philadelphia Resins believes that proper foundation design to assure maintenance of alignment is an integral part of the engineered system of machinery design in which the two cannot and should not be separated. Historically, critically aligned machinery was full bed grouted on the concrete block using first cementitious grout and later epoxy grout. It was found that in the case of cementitious grout, oil and chemical contaminants could and did migrate down to the concrete block, causing extensive block deterioration. In the middle 1950s, epoxy grout was substituted for the cementitious grout because it was impervious to oil and many chemicals and had a much shorter cure time. However, thermal growth of equipment caused cracking of the epoxy cap, thereby opening a path for oil and chemical contamination. In addition, this design using either of the above grouts trapped undue amounts of heat under the machinery and in the concrete block, which caused thermal humping of the crankshaft. It was found that by raising the machinery on epoxy chocks, airflow circulated under the engine, reducing temperatures not only in the machine, but also in the underlying concrete foundation. Since the epoxy chocks are allowed to move with thermal expansion, there is no cracking in the grout cap, thereby eliminating a pathway for oil and chemical contamination of the concrete block. This design greatly reduces the chance of broken crankshafts and the cost of bearing maintenance. To achieve this engineered concept, one must have a sound base foundation. The concrete foundation must be clean and dry, with no oil contamination and free of cracks. All anchor bolts should be isolated in order that the bolts will be allowed to stretch. Proper bolt tension can only be achieved by allowing for proper stretch of at least 12 bolt diameters. As the illustration shows, bolts that are bound allow no stretch and will continually be a problem in maintaining tension. In placement of bolts, a collar should be set in the grout so that if bolts do break in the future, the broken piece can easily be removed and a new stud inserted, thereby eliminating the need of cutting into the foundation to replace broken anchor bolts. Care should be given to using the thinnest amount of isolation material around the anchor bolts consistent with providing for free stretch of the bolts, approximately 1/8 inch. This is important because epoxy chocks are loaded essentially on a 45-degree angle off the center of the bolt. It is obvious that the thicker the isolation material, the less load-bearing area on the chocks, thus the less area available for effectively holding down the machine and maintaining permanent, precise alignment. It is very important to have strong, leak-free forms when pouring epoxy grout. Because epoxy grouts are heavy, these forms should be braced vertically and horizontally. All areas of the forms that are to come in contact with the epoxy grout should be waxed with at least 2 coats of a good quality paste wax. Under no circumstances should liquid waxes be used. In addition, all inside 90-degree corners should be chamfered by use of chamfer strip wood moldings nailed to the forms. The use of chamfer strips helps eliminate stress in the epoxy grout and also is a safety factor in eliminating sharp corners which can cause cuts to personnel who may accidentally fall against them. Because the coefficient of expansion of steel reinforcing bar is so much less than epoxy grouts, it is recommended that no horizontal rebar, as it is known, be left in the grout pour area. Horizontal rebar is necessary in concrete to give it additional strength, but since epoxy grouts are so much stronger than concrete, the rebar is actually a disadvantage when used with epoxy grouts. Horizontal rebar can cause severe cracking in epoxy grouts because of the difference in coefficients of thermal expansion between the two materials. Vertical rebar around the perimeter of the concrete block is recommended because it tends to help counteract the curl phenomenon of epoxy grouts as they cure. In order to equalize the expansion and contraction and protect the concrete block from oil or chemical contamination, Philly Bond 7C is used to anchor the expansion joint material to the concrete block. At this point, 20 mesh clean, sharp sand is mixed with the Philly-Bond 7C to make a no-slump mortar, which assists in holding up the styrofoam or redwood expansion joint material, which are most commonly used. Temperature preconditioning is imperative in using epoxy grouts. This means that material shall be stored in such a manner that it does not absorb ambient high temperatures in the summer nor ambient cold temperatures in the winter. The epoxy should be near 72 degrees Fahrenheit through use of indoor storage and ventilation in the summer, or indoor storage and artificial heat during the winter. If this is not done, undue stress will be cast into the epoxy grout, causing difficulties as to cracking in the future. In addition to proper preconditioning of the grouting materials, attention should be given to the temperature of the concrete surfaces to receive the grout. If the concrete block has been allowed to absorb great amounts of heat, or in the case of winter, reduced to an extremely cold temperature, under 55 degrees Fahrenheit, this will induce unwanted stresses in the cured grout cap, possibly causing cracks in the future. The epoxy grout should be stored at approximately 72 degrees Fahrenheit for 24 hours prior to its use. When selecting an epoxy grout that will interface with the concrete foundation, one should try to choose a grout with a low coefficient of thermal expansion, such as Chock-Fast Red. From the chart, we see that concrete has a coefficient of thermal expansion of 5.9 times 10 to the minus 6 inch per degree Fahrenheit. While Chock-Fast Red has the lowest thermal coefficient of epoxy grouts today at 11.2, it is still higher than concrete. Notice that other epoxy grouts on the market go much higher, even up to 28. This means that it is much harder to control the thermal expansion and contraction of the epoxy grout as the coefficients of thermal expansion values increase. Because Chock-Fast Red has such a low exothermic temperature reaction and a low coefficient of thermal expansion, it can be poured in excess of 18 inches deep at 42-inch intervals. With most other epoxy grouts, the thickness of the pour must be reduced considerably, and the interval spacing of expansion joints is also severely reduced. Chock-Fast Red is supplied as a 3-component unit consisting of a 1-gallon can of hardener, a 3-gallon slack-filled resin can, and 4 46-pound bags of aggregate, which will yield a compressive strength of 12,000 psi. The hardener is poured into the slack-filled resin can and mixed at 250 RPM for 3.5 to 4 minutes with a medium-sized Jiffy mixer blade, and then poured into a mortar mixer, or in the case of small pours, a wheelbarrow. And the 4 bags of aggregate are then added and mixed until a flowable mix is obtained. This will typically take 3 to 5 minutes of time at 70 degrees Fahrenheit. Now, Chock-Fast Red is ready to be poured into a wheelbarrow and then into each form at 42-inch intervals until the desired thickness is achieved, up to 18 inches deep maximum. Because of its weight, care should be taken to pour Chock-Fast Red equally on both sides of the styrofoam expansion joint to prevent the forms from being pushed over. After the Chock-Fast Red has been poured, tools and equipment are easily cleaned with water